I went to Stanford as a graduate student. We worked on network protocols, in particular what led to the development of TCP/IP. My part was to build some interfaces to connect the PDP-11 to the ARPANET, which was our communication medium at that time. And my office mate, Jim Mathis, wrote the TCP/IP protocol, a prototype of that, which fit in by today's standards, a very tiny amount of memory. From Stanford, I moved, a number of us started moving toward Xerox as it was time to graduate. And I went there as well. I worked for Bob Metcalf. And at Xerox, we were working on network communication development. We were in a communication group. One of our early projects was to come up with a commercial version of Ethernet, and we were looking to make a higher speed version, and part of the job was to figure out how much higher speed. But there were some limitations in the coax cable in terms of reflections. The key limitation I was looking at was if the cable posed a limit, because we could get by the digital technology. That was a relatively short time delay, even in those days, to get to a higher speed. So we wound up running at 10 megabits a second. I left Xerox at that point in time and joined 3Com, and we started building product. We had some development contracts to build, and we also developed Ethernet controllers and transceivers, and we're also looking for venture capital. We continued with that development effort and built many computer interfaces. So we sold a number of these mini computer controllers, but they cost thousands of dollars and contributed to a perception early on that Ethernet was extremely expensive, simply because it was. And then IBM came out with their product, the IBM PC. So we got a hold of some early specifications for that and looked at it, and then as soon as we could get an actual machine, we did that and came up with a design for an Ethernet controller that would fit on a single board within the IBM PC. We were able to include both the controller and the transceiver on the board. We built the board with a BNC connector sticking out the back, which was the connection to the coax cable. We plugged a BNC-T connector on it and called it Thin Ethernet. And this wound up to be, along with the software product, which was email and file sharing, was very successful. So we had what every startup looks for, the so-called killer application, and proceeded to sell a lot of these boards. And then 3Com got into the business and then built our own servers for a number of years. And near the end of the server period, we also started building bitmap graphics workstations with built-in Ethernet controller. They're basically a net station. It had no disk, so the idea was to have a diskless workstation. It could boot from one of the servers on the network. In 1987, we came out with a twisted pair Ethernet product. This was an extension of just the thin coax system. So I was at 3Com up until from 1980 to 90, and then started doing some consulting and wound up working with some gentlemen who had previously had a company called David Systems, which was also one of the early twisted pair Ethernet companies. And at one of the meetings, I remember hearing someone raising the issue, which was very good. He was doing exactly the right thing, but I was somewhat frustrated. So I started thinking, well, gee, we could make Ethernet go faster. And so I kind of worked through the same stuff that I did when we did the switch from 3 megabits to 10 megabits at Xerox. How much do we have to shrink the network diameter? What is the minimum packet size? What is the minimum round trip time? And it appeared that we could, with a 100-meter distance to the desktop, if we went to 100 megabits, everything would work. So it occurred to me, gee, maybe we could make this go faster. Independently, I was meeting with friends who were looking to start a new company, and we had been talking about test equipment. And on one day, someone was asking, why can't Ethernet go faster? And I thought for a moment, I said, well, well, I might as well tell them. So I did, and the guy had, this was Howard Charney, had done an excellent job of figuring out what the market size and everything else was for possible test equipment, and it only took him a microsecond to figure out that if he could sell every node on the network rather than maybe a piece of test equipment on some number of node segments, this was a big opportunity. So they started a company called Grand Junction Networks that built faster Ethernet product. So they were one of the early players in that market. Many other companies followed. They were eventually acquired by Cisco, as was Crescendo, the company that had developed 100 megabit FDDI. So everybody found a home at Cisco. I was part of a talk about 2 or 3 years ago, which dealt with how interconnects between computers in a cluster would be done. Would people use Ethernet, that is 1 or 10 gigabit Ethernet, or Miranet, or Quadrix, or InfiniBand? And it seemed that all of the vendors at that talk, the talk was Ethernet or Ethernot. And we all decided that the answer was Ethernet, because each of the vendors, and each for a different reason, had decided that they were going to offer their product with a version, with an option or a mode that would operate in a straight Ethernet mode. Their board of directors had a meeting and said, we looked at Ethernet and we figured if we only got a teeny tiny fraction of Ethernet market share, that would double our sales. That made it an easy decision for them. And I think the technical people quickly followed along as well, simply because Ethernet controllers are trying to basically do everything people want for packet communication. Ethernet initially was really the purest form of datagram embodied in hardware. Controlling it was very simple. And I believe that's what's led to the success and the ease of standardization for Ethernet. And that should continue. Where will we be in 35 years? I can only imagine that we'll just be running at much higher speeds. The packet formats will probably be not too different. There will be many more protocols carried by the packets, and the transmission medium will change.